433, minimum genetic mutation. I think you should understand about this problem. We are given a string with the start gene. Let's check the length of the string. So the length of the string is 8, so it means it's not a big value. And the length of the bank is 10. Yeah, it's also not a big value. So this means for this problem, we can use BFS to solve it. Yeah, because for each of the time, there's only one of the genes will mutated to another letter. For example, there will be a letter A will be mutated to C, G, or T. Yeah, for one time. We just need to check what is the minimum steps of the mutation. Yeah, so we are giving start gene and add gene, and the gene bank return the minimum number of mutations needed to mutate from start gene to add gene. If there's no such mutation, we're gonna return a -1. So this is a typical BFS problem. We just use BFS to search, and we're gonna get the minimum steps. So let me put a Q should be equal to the Q, and inside I'm gonna prepare a tuple. It's gonna be start gene with the steps. It's gonna be 0 steps, and then I'm gonna prepare a visited set, and inside it's gonna be the start gene. Yeah. Now let's just check the Q. So while Q, I'm gonna pop the gene. So one of the gene and the steps should be equal to Q dot pop left. Yeah. So I'm gonna pop it from the left side. Now I'm going to mutate this gene. So how can I mutate? I just need to check one to another. So I'm gonna use a for loop. So for I in range less of gene, yeah. And here I'm gonna have yeah. So what should I do? I'm gonna check a letter. So for example, if this letter is A, so this A can be mutated to other 3 letters like C, G, and T. So how can I do that? I can prepare a data structure like a dictionary. So here I use a J. So this J inside, if it is the letter A, it will be mapped to an array of C, G, and T. And similarly, I'm gonna just use a copy and paste to prepare on this kind of result. Yeah. So if it is C, I'm gonna change this to A. If this is G, I'm gonna change this to what? I forget. And change it to A. And if this is T, I need to change the T to A. Yeah. Now let me just make a little bit alignment, and yeah, we just start continue. Yeah, because we can use this kind of graph to solve the problem. Yeah. So it's gonna be like this. So this is our graph. Yeah. So for I in range gene, I'm gonna prepare our new gene. What is the new gene or the mutate? Mutation. Yeah. So the mutation. Yeah. Let me use another one. So for neighbor, let me just use neighbor. So for neighbor in graph with this gene. Yeah, with this gene I. Yeah, so this neighbor will be just a letter. For example, if it is A, it's gonna be C, G, or T. Yeah, so for example, if the first letter is A, then this neighbor gonna be this character C. Yeah, so for example, now I'm gonna create the new gene. Yeah, so this new gene would be my gene add with I plus this neighbor and plus the gene and start with I plus 1. So this gonna be my new gene, and this new gene will put it inside the queue. So I have to check if this new j in bank. Yeah. Although this bank is really small because the length is only 10, but I need to put it inside a set because inside a set the time complexity becomes O1 if you visit a set. So I'm gonna use a set would be equal to set with this bank. Yeah. So if new j inside the or I just need to use a bank. Let me just use a bank variable. If it is inside a bank and this new j not in visited, so I'm gonna put it inside the visited. So visited should end this new j. And similarly for the queue should append this new j. So it's gonna be new j and steps would plus 1. So for here, if I find a result, so for if this j equal to the result, it would be end j. So I'm gonna return the steps. Yeah. I think the difficult part about this problem is how to analyze the time complexity. Yeah, the time complexity is not a big value. If you didn't find it, you're gonna return a -1. Yeah, if there's no possible result, you're gonna return this -1. Yeah. Now let me analyze the time complexity first before submitting the problem. Yeah. So for the time complexity, because this bank is really small, that is why we can pass for BFS. Let's check these areas. And for I in length j, so for I in length j, here will be 8, and for neighbor will be 3, because for each of the character like A, there will be 3 numbers. So here would be 8 times 3 would be like 24. Yeah. But we're gonna check the new j inside the bank, and how many new j's? There's only 10. So this means the time complexity is 24 times 10. It is basically like 240. Yeah, this is why it can pass, and it's really fast. Let me just submit it to check if it works. Yeah, I should always check it before submitting. Step is not defined. So where is my step? Yeah, here I had a typo. Let me run it first. Yeah, now as you can see it works. Now let me submit it. Yeah, as you can see it's really fast because the time complexity is just 8 times 3 times 10. Yeah, because we use the visited set and every j should always inside the bank. If it is not inside, we're gonna not put it inside the queue. If it is inside the bank, we're gonna put it inside this queue. And how many of them? There are at most 10. And this is why 8 times 3 times 10 gonna be the time complexity. And the space complexity here it is O1, and this is also O1 because there's only 10 elements. Yeah. So basically for the I'm not sure, let me just check. Yeah, but the queue it takes but for this queue, how many genes will be inside this queue? There will be at most 10. Yeah, because if it is inside the bank, and then it's gonna inside the queue. Yeah, so for the space complexity it is O10. So 10 is a constant number, it is O1, and the time complexity is 8 times 3 times 10, it is 240. It is also similar like O1. That is why it is so fast. So yeah, it's just because the data, all this data for this problem, all the testing cases is really small. That is why it is so fast. Thank you for watching. See you next time.